Hi, my name is Manish Gupta, and in this video, I'm going to talk about Zephyr, which is a model fine-tuned from Mistral 7 billion. Okay, so let's talk about how is Zephyr trained, okay, and why is it important, okay? So Zephyr has been trained by starting from Mistral 7 billion, and it has been trained using these three steps, which have now become the most recent way of training awesome models, okay, awesome language models. These steps are dSFT or distilled supervised fine tuning, AIF or artificial intelligence based feedback, and the third one is dDPO, which is basically distillation from direct preference optimization. Okay, so let's talk about each of these one by one. So you start with Mistral 7 billion, and then you essentially also have some large teacher models. Okay, so these teacher models could be, let's say, GPT-4 itself, or these teacher models could be Claude, Llama 70 billion, and so on. To these teacher models, you basically, take a few prompts of this kind, create a scenario for a game about space exploration, and you essentially get these outputs from these teacher models. So you use these large teacher models, and you basically get responses from these teacher models. You basically get multi-turn responses, and you pass these multi-turn dialogues to Mistral 7 billion, and you do supervised fine-tuning of Mistral 7 billion. So Mistral 7 billion is, remember, a smaller model, but these teacher models are much larger in size. So this Mistral 7 billion now tries to simulate multi-turn user assistant interactions that were generated using some larger teacher models. And that is what you basically call as the distilled supervised fine tuning. You essentially, get some dialogues from large teacher models, and you distill your Mistral 7 billion using those. In general, in this particular Zephyr work, they actually did distilled supervised fine tuning using UltraChat dataset, which is already publicly available. Okay. This gives you your initial policy or model called as dSFT. Now, in the second step, what you do is to basically take a whole bunch of such random prompts. So sample a set of prompts from a data set of prompts. Okay, so sample a few prompts. Okay, you pass those prompts to some really large teacher models. So for example, they actually experimented with Claude, Falcon, Llama, and so on. You basically get responses from them for those questions. Describe how to make chocolate brownies. Okay. Now use GPT-4 to rank these responses. You got like 4 responses, fine. You basically rank them. And let's say the most preferred response from GPT-4 is YW, and YL is some random response out of the remaining 3. Okay, not necessarily the worst response as scored by GPT-4, but some random response. One of the three basically. Okay. And then in the third step, what you do is to basically do direct preference optimization using this using these YW, YL pairs for this query X. Okay. So you take the same query X as you have here. You basically take the YW, take the YL, and then you do direct preference optimization. So in one of the previous videos, I've sort of covered how DPO, or the direct preference optimization, is being preferred over RLHF these days. It does not really require sampling from your original model. It does not require reinforcement learning. It's basically just a simple binary cross entropy loss based optimization. And they basically show how this optimization still tries to use the LLM to mimic a reward model. So no explicit reward model needed, but you can actually do optimization. It's a much more simpler way of doing preference optimization using preference data. Okay. So that's that. Now in dSFT, there is one small little tweak. So rather than actually using these responses or dialogues from your teacher model directly, what you could do is to use a self-instruct protocol, which basically means you could take these seed prompts and then ask the teacher not just to give you the answer, but also a revised prompt itself. That basically just improves the prompt quality by itself. Okay, but otherwise, it's basically just the 3 simple steps. Do distilled supervised fine tuning, do artificial intelligence AI feedback so as to essentially avoid human labeling, right? And third, you do distillation using DPO, distillation using direct preference optimization. So in this particular case, Zephyr case, the original model is Mistral 7 billion. They did the dSFT using UltraChat dataset, and they did DPO, AIF using these models, Claude, Falcon, Llama, and GPT-4. And they do, distilled DPO using the ultra feedback dataset, which is also another public dataset. Okay, so how does this Zephyr model perform? Why are we talking about it, right? So basically, they measured performance on two different benchmarks. So the empty bench benchmark, which is basically a benchmark of several multi-turn, conversations. And they also did a comparison on the public open LLM leaderboard, which is a combination of these four different academic data sets. Okay. So what do they observe? So they compared with the other models which are of 7 billion in size, which are 7 billion in size. They also compared with other larger LLMs, which are much larger, right? And they compared with, but these are open. The middle block is open. And they also compared with the closed API access based models like GPT 3.5, Turbo GPT-4, and Claude 2. Okay. Of course, each of these models have been trained in different ways. For example, MPT stable LM have been trained using just dSFT, just the supervised fine tuning, but others have also been trained using PPO, RLHF algorithm, and dPO, for Zephyr. Okay. So similarly, the larger models have also been trained using their own philosophies. The super large closed source models actually have been trained using RLHF. What you observe is that um, amongst these 7 billion models, Zephyr gives you the state-of-the-art performance, the best performance on both the empty bench and also another dataset called as Alpaca Eval. Right? Gives you really good performance. This performance is even better compared to the XWinLM model, which was basically which is known to be really good, but it has been PPO distilled. Okay, using RLH, using reinforcement learning in that sense. Okay. Now, if you compare Zephyr with the Falcon Instruct, which is like a 40 billion parameter model, the 7 billion Zephyr is still better. 5.71 is, 7.834 is still better than 5.71. Of course, it's also better than the 65 billion parameter model and so on. Several other models, it's actually better, but of course, it is not as good as Wizard LM model, which basically means that if you increase the model size, Zephyr's model size, hopefully you'll see better results also. That's that. Now, if you, so basically, an interesting point to see is that Zephyr 7 billion actually can also beat your Llama 2 Chat 70 billion model, which is really a good thing. This chart basically shows the split of this empty bench benchmark. So there are several kinds of tasks in it and across different domains. So humanities, role play, reasoning, and so on. And as you observe, Zephyr particularly performs poorly, let's say on coding and math. So Zephyr is this green curve, right? While on humanities and writing, it is actually as good as as good as GPT 3.5 Turbo for that matter. Okay. So that is that. In fact, even here, if you look at it, 7.34, or rather this Alpaca eval performance, 90.60 is better than GPT 3.5. However, you do observe the GPT 3.5 is actually better in terms of coding and math, significantly better. Okay. Now, the story is pretty similar on the OpenLM leaderboard. So you see that Zephyr basically performs better across tasks, across these different benchmarks, in the 7 billion parameter range. But of course, in the larger parameter range, there are models which perform way better. So larger the model, maybe you can actually, if you increase the size of Zephyr, you probably would observe similar kinds of accuracies. Okay, so in summary, in this video, I talked about the Zephyr 7 billion parameter model, which is based on Mistral 7 billion, and then 3 steps of training. So distilled supervised fine tuning using the UltraChat dataset. Then using the UltraChat dataset, then you do AIF using the 4 teachers and GPT-4, and then you do distilled dPO using the ultra feedback dataset. Zephyr 7 billion established state of the art, for 7 billion chat models. In fact, it is better than even Llama 2 chat 70 billion parameter model on empty bench benchmark. It's also state of the art on for 7 billion parameter models on the OpenLM leaderboard. Okay, so that's it about Zephyr 7 billion. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage.